Okay, so in this video, I'll be explaining how you would solve different types of related rates problems. The first example we have is a kite 40 meters above the ground moves horizontally at the rate of 3 meters per second. At what rate is the angle between the string and the horizontal decreasing when 80 meters of that string has been let out? The first thing you would do is draw out your diagram to better understand what it is you are dealing with. By using the tan theta equation, you can find the derivative of that equation. Secant squared theta times d theta dt equals negative 40x to the negative 2 times dx dt. To find d theta dt, you move everything over to one side. Keep in mind that 1 over secant squared theta is the same as cosine squared theta. To find x squared, you use the Pythagorean theorem, and that would give you x squared equals 4,800. Plugging in the x squared to the cosine squared theta equation, you get cosine squared of theta equals 3 over 4. Once you have everything you need, you plug in 3 over 4 for cosine squared theta times negative 40 over 4,800 because it's x squared times 3. Our next equation is water is being poured into a cone-shaped cup at a rate of 50 centimeters cubed per second. If the cup has a height of 8 centimeters and a maximal radius of 3 centimeters, how fast is water rising when it is 4 centimeters full? For this equation, you would have to find the ratio between the smaller part of the cone and the whole cone itself. You would have to use the equation 8 over 3 equals h over r. Using the volume equation for a cone, you plug in 3 over 8 h into r squared, giving you 3 pi h to the third all over 64. Find the derivative of that equation. Plug in your given information, 50 for dv/dt, 4 for the height. After calculating everything, you find that dh over dt equals 200 over 9 pi centimeters per second. Our final equation for related rates is an inverted conical container has a diameter of 6 inches and a depth of 15 inches. If water is flowing out of the vertex at a rate of 2 pi inches cubed per second, how fast is the depth of the water dropping when the height of the water is 10 inches? In this equation, you are finding dh dt. Using the same ratio that we used in the previous equation, you would have r over h equals 3 over 15, giving you r equals h over 5. Again, using the volume equation for a cone, plug in h over 5 into r. Find the derivative of the volume. Plug in your given information, cancel out pi, and you're left with dh dt equals negative 1/2 inches per second.